Hello guys, welcome to our class for today. This is Normal Science Tutors Online. In this channel, we bring physics class to your doorstep. So today we are going to be discussing centripetal acceleration, centripetal force, and centrifugal force. Remember, in our previous class, we discussed circular motion. So this is a continuation lecture on circular motion. So for today, we are discussing centripetal acceleration, centripetal force, and centripetal and centrifugal force. So please, you can always reach us through the WhatsApp number that is showing on your screen. If you have not subscribed to this channel, please subscribe to this channel. Give us a like, give us a thumbs up. You can always place your comment on the comment section down below. So please, for us to continue with our class, get your writing materials and get settled for this class. I will also encourage you to tell your friends, invite your schoolmates so that they can also come and enjoy this lecture that you are enjoying on YouTube. Alright, so welcome to the class for today. We are going straight now to continue with our class on circular motion, and today we are discussing centripetal acceleration, centripetal force, and centrifugal force. So what is centripetal acceleration? Centripetal acceleration is acceleration directed towards the center of a circular path for a body that is describing, or for a body that is undergoing circular motion. That is centripetal acceleration, the acceleration that is directed toward the center of a body that is undergoing circular motion. That is centripetal acceleration. So for a body that is undergoing centripetal acceleration, the equation for that centripetal acceleration can actually be derived. Okay, so if you look at this diagram, it is depicting a body or a particle that is describing a circular path. So you see that the acceleration is actually directed inward, while the velocity that it is using to describe the path is at a tangent to the circular path. Is that okay? So the centripetal force is also directed inward. This is the force that acts on this body and it is directed inward. While the centrifugal force is the force that is opposite to the centripetal force and it is directed outward. And that is what this arrow indicates. This is centrifugal force. It is the force that is acting on a body that is describing a circular motion and it is directed outward. Okay, so centripetal force is that force that acts inward to keep an object moving along a circular path at constant speed. While centrifugal force is the force that acts outward opposite to centripetal force on an object moving in a circular path. So that is what I just described on this in this diagram. Now, having gotten this definition, what is the formula for centripetal acceleration, centripetal force, and centrifugal force? So that is what we are going to derive very shortly and very quickly too. Okay, that's what we're going to derive very shortly and very quickly. Centripetal acceleration. Okay, so we've defined centripetal acceleration. So now we want to get the equation for centripetal acceleration. Remember that from our last class on circular motion, we got that linear velocity is related to angular velocity by this equation. V is equals to rho w, right? And we also got that acceleration is equals to rho w squared. Okay, so from equation 1 we can make w the subject of formula. So w will give us equals to V all over R. Now if you substitute for W into this equation, it will give you that A is equals to R V squared all over R squared. So by the time you cancel this out, you are going to have that A is equals to V squared all over R. So this is your centripetal acceleration. This is your centripetal acceleration. Now your centripetal force, you know that force is equals to what? Mass times acceleration. So if the mass of the body is represented by m, then acceleration is represented by v squared over r. Then your centripetal force that is directed inward is given by mass times v squared all over r. So this you can actually write it as m v squared all over r. So this is your centripetal force. Centripetal force is equals to, it's given to you to be m v squared all over r. And this is the force that is directed inwards to keep the body in the circular path. We know that the centrifugal force is opposite to centripetal force, so centrifugal force will be equals to negative minus v squared all over r. So this is how to derive this equation for centripetal acceleration, centrifugal force, and centrifugal force. So this is centrifugal force and this is centripetal force. So these are the equations for centripetal acceleration, centripetal force, and centrifugal force. So now we'll go straight to how to apply this equation to solve some problems. That okay? So we're going to solve some problems now. Okay, so this is what I just discussed and described. You can actually put this down in your notes. I want you to take note of this, that when a stone tied to a string which is wide in a circular path is suddenly cut, the stone will fly off at a tangent to the circular path. If you check most of your JAM questions, you will see questions related to this, questions that have this type of statement. So take note that even if any object that is describing a circle, if the string cuts, the object will fly out through the tangent to the circular path. Take note of that. Okay, so we are going straight now to solve some problems related to these equations that we just derived. This we've already discussed, so take note of this. Centripetal force equals to mass times centripetal acceleration, which gives you that. Centrifugal force equals to centripetal force, and this is what you have. I said that in our last class that one complete circle describes an angle of 360 degrees, and this is equals to 2 pi irradians. Okay, so this is 2 pi, 360 degrees equals to 2 pi irradians. Right, so now we're going straight to solve some problems. So this is an example problem that we need to solve. Okay, so this question says an object of weight 150 Newton moves with a speed of 4.5 meters per second in a circular path of radius 3 meters. Calculate centripetal acceleration and the magnitude of the centripetal force. Take g to be 10 meters per second squared. So what are you giving in this equation? You are giving velocity to be equals to 4.5 meters per second. You are also giving the weight of the object to be equals to 150 Newton. We are giving radius to be equals to 3 meters. and you are asked to find centripetal acceleration A and the magnitude of the centripetal force F. When you are solving any physics problem, it's always good that you bring out the known and the unknown variables, so that when you know the equation to apply. Now, for this particular equation, we are going to first of all find the centripetal acceleration. Centripetal acceleration A is equals to v squared all over r. Now we already saw we know that v squared is 4.5, then r is 3 meters. So just substitute into this equation, you have 4.5 squared all over 3. Okay, all over 3. So if you work this out, you will have, when you work this out, multiply this out with your calculator, you are going to have 6.75 meters per second squared. So this gives you your centripetal acceleration. Now, for you to find the magnitude of centripetal force, F is given as mass times centripetal acceleration, which is v squared over r. Now, here you are given v to be 4.5, r to be 3 meters, and the weight is given to you. So what you do first of all is that you are going to find the mass of this object. You know that weight is equals to mass times acceleration g due to gravity. So the mass of the object will be equals to what? Weight all over g. So that gives you 150 all over 10. So when you cancel that, you are going to have 15 kilogram as this is now your mass. So you can now substitute this one into this equation to give you 15 times. You already have the acceleration. This is already your centripetal acceleration. So multiply by this one, 6.75. If you work that out, you are going to have, punch that in your calculator. So you are going to have 101.25 Newton as the magnitude of your centripetal force. So from here you can see how to solve problems that has to do with centripetal acceleration and centripetal force. Is that okay? First of all, look at the question very well so that you know what to do. This weight, you have to get your mass from it before you use it to solve for your centripetal force. Alright? Okay, so this is another sample problem. A stone weighed at the end of a rope 30 centimeters long makes 10 revolutions in 2 seconds. Find 1. The angular velocity in radians per second, 2. the linear velocity, and then 3. the distance covered in 5 seconds. Okay, so for this particular problem, we also bring out what we are giving. We are giving radius to be equals to 30 centimeters. So if you convert that to meters, you are going to have 0.3 meters. I'll divide this by 100, so that gives you a radius. Then we know that one revolution 1 revolution is equals to 360 degrees, which is the same thing as 2 pi in radians. It's 2 pi in radians. That okay? So which means that 10 revolution will be equals to what? To be equals to 10 times 2 pi in radians. In radians. So that will give you 20 pi in radians. Okay, that will give you 20 pi in radians, which is the angular displacement. This is the angular displacement of the stone. Then the time is given to you to be equals to 2 seconds. So these are what are given to you. Now we want to find the angular velocity in radians per seconds. Angular velocity in radians per second. From our previous equation, we are told that angular velocity is equals to what? Angular displacement all over time taken. So if you bring those values into here, your angular displacement is 20 pi radians, right? So that gives you 20 pi radians divided by the time. Our time is 2 seconds. So divided by 2. So cancel this one out, you are going to have 10 radians. So your pi is 3.14. So that gives you 10 times the value of your pi, 22/7 or 3.1414. Okay, so when you multiply this one at 14 radians per seconds, so if you work this out, you are going to have 31.4 radians per seconds. 21.4 radians per seconds. That's what you have. So this gives you the angular velocity of this stone. Alright, so now I want to find the linear speed. The linear speed. From our previous equation, we've got that linear speed is related to angular speed or angular velocity by this equation. V is equals to rho w. So substituting to this equation, we have the radius is 0.3 meters. So we have 0.3, which is the radius, multiply by the angular velocity that we just got. Okay, so if you multiply this out, you will have that your linear speed will be 9.42 meters per seconds. This will give you your linear speed, right? So you see how the equations are coming up. Then the distance covered, we had that your linear speed is equals to displacement all over time. Therefore, displacement will be equals to what? Displacement s, which is distance covered, is equals to linear velocity times time. So if you substitute the values to this equation, you are going to have your linear velocity is 9.42 multiplied by the time that is given, which is 5 seconds. So if you do that multiplication with your calculator, you are going to have 47.1 meters as the distance covered in 5 seconds. So guys, this is how to go about solving problems involving circular motion, angular velocity, centripetal acceleration, and centripetal force and centrifugal force. Okay, so I hope this is simple and they are easy for you to remember. Please just try and try your hands more on other questions. So now you go to your test page. So these are more questions for you to work on. Please try to solve these problems. Question number 1 says that a force F is required to keep a 5 kg mass moving around a circular radius 3.5 meter at a speed of 7 meters per second. What is the speed if the force is tripled? A particle of mass 10 raised to the power minus 2 kg is fixed to the tips of a fan blade which rotates with angular velocity of 100 radians per second. If the radius of the blade is 0.2 meters, the centripetal force will be what? So these questions are actually jam questions. So please guys, try your hands for them. You can solve it on a piece of paper, snap it and put it on my WhatsApp number. I will make my comments whether your answer is right. The method you use of solving it is okay. I'll make my comments. Okay, so thank you so much. This was ending this class for today. So please, if you have not subscribed to our channel, please subscribe to the channel, click on the notification bell so that whenever we upload video, YouTube will notify you. And this is Noble My Science Tutors Online, and we are bringing physics class to your doorstep. You can reach us through the number that is showing right now on your screen. The WhatsApp number, you can add us up, send any question you have, we'll help you to solve it and also discuss with you on how you can improve your knowledge in physics. So thank you so much. Give us a thumbs up if you like what we are doing. Comment on the comment section and then give us a like. So we'll see you in our next class. Thanks.